Right now, somewhere in your dark bedroom, your eyes are moving fast and sharp, completely beyond your conscious control. Your body lies still, your breath is shallow, your muscles are paralyzed, but your eyes are scanning something invisible. They dart left, right, up, and down with the precision of someone watching a tennis match no one else can see. This happens 4 to 6 times every single night for about 90 minutes total across your entire life. Welcome to one of the strangest secrets your brain keeps from you, what scientists call rapid eye movement, or REM. We know exactly when it happens, we can measure it down to the millisecond, and we can map every brain region involved. But there is one question we still cannot answer with certainty, even after 70 years of careful neuroscience research. What exactly are your eyes watching during those 90 mysterious minutes every night while your conscious self sleeps? The first scientist to observe this was Eugene Aserinsky in 1953, a graduate student desperate to finish his doctoral thesis. He hooked his young son to a primitive electroencephalogram, hoping to map basic brain waves during normal sleep. What he found instead changed neuroscience forever: bursts of intense brain activity, perfectly timed with rapid eye darting. His son was deeply asleep, body limp, breathing slow, but his eyes were behaving as if he were wide awake. Aserinsky woke him up and asked what was happening, and his son described a vivid, deeply unsettling dream. The connection was instant. Eye movement, brain activity, and vivid dreams were somehow linked at the deepest neural level. Tonight, we will walk through what science actually knows, and what still remains a genuine mystery to researchers today. Because the answer to what your eyes are watching may be far stranger than you have ever imagined possible. Every night you cycle through 4 stages of sleep, beginning with light sleep, then deeper sleep, then deepest delta sleep. After about 90 minutes, you enter the 5th stage called REM, and your brain suddenly lights up like daylight. Brain activity in REM looks identical to waking life on every measurable scale: frequency, voltage, rhythm, and neural intensity. But your body is in deep paralysis, muscles locked down by chemical signals from a brain region called the pons. This paralysis exists for one reason that nearly every researcher agrees on: to stop you from physically acting out your dreams. We have seen patients with damage to the pons who do not become paralyzed, and they punch and run in their sleep. So your body lies silent, your breath is shallow, your heart rate becomes variable, but your eyes are completely free. Your eyes can move because the brain regions controlling them, the brainstem and pons, are not paralyzed at all. They are, in fact, more active during REM sleep than they are during most of your normal waking life. The big question scientists have been asking since 1953 is whether these eye movements carry meaning or are merely noise. The first theory was simple and almost beautiful. The eyes are scanning your dream, watching events as they unfold. If you dream you are climbing a mountain, your eyes look up, then left, then right, tracking the imaginary terrain. Experiments in the 1970s seem to confirm it. Researchers correlated specific eye movements with reported dream content. A subject reported playing tennis in a dream, and their eye movements perfectly matched the lateral ball tracking pattern. Another subject reported climbing many stairs in a dream, and their eyes moved vertically in a clear stepping pattern. The scanning hypothesis dominated for decades, taught in medical schools, and printed in every neuroscience textbook of the era. But then a problem emerged that the simple theory could never explain: the case of people who are congenitally blind. People born without sight, who have never seen anything in their lives, still enter REM sleep every single night. Their eyes still move in identical patterns, at identical frequencies, even though they have no visual memory to scan. If the eyes were truly scanning visual content, why would someone who has never seen anything still have REM eye movement? Scientists studied dreams reported by blind people and found something extraordinary. They dream in sound, touch, smell, and taste. Their dreams are rich and complex, but contain almost no visual imagery, and yet the REM eye patterns remain identical. This shattered the simple scanning hypothesis and forced scientists everywhere to seriously reconsider what REM sleep actually is. A second theory emerged. The eye movements are random, generated by the brainstem with no relation to dream content. This is called the activation synthesis model, proposed by Harvard psychiatrist Alan Hobson and colleagues back in 1977. In this view, the brainstem fires random signals, your eyes twitch as a side effect, and dreams emerge from interpreting the noise. It is an elegant theory that explains the blind case, but it also has problems. The movements are not actually random at all. Statistical analysis shows REM eye movements have structure, patterns, and rhythms that purely random neural firing cannot ever produce. They cluster in bursts of 3 to 15 movements, separated by pauses of strangely consistent length and timing. In 2017, researchers in Israel and France made a discovery that revived a much deeper version of the scanning theory. They studied epilepsy patients who had electrodes already implanted deep inside their brains for delicate, precise surgical mapping. These patients allowed scientists to directly record individual neurons firing in the medial temporal lobe during REM sleep. The medial temporal lobe is where your brain processes visual scenes, recognizes faces, and identifies places when you are awake. And here's what they found. Those same neurons fired during REM in tight bursts perfectly timed with every eye movement. Every time the eyes flicked to a new position, neurons fired as if the brain were processing a brand new visual scene. The exact same neurons, with the exact same firing patterns as when the subject was looking at a real photograph. It is as if the sleeping brain is presenting itself with a slideshow, and the eyes are turning to look at each image. This is now called the dream image scanning hypothesis, and it is currently the strongest theory neuroscience has. But here is the deeper mystery. These neuron firing patterns happen in blind people too, even without any visual content to scan. So the brain is somehow generating internal images that the eyes track, even when there is no visual experience to actually track. Some scientists now believe REM eye movement is the brain rehearsing perception itself, training the visual system from the inside out. Others believe REM is a form of deep memory consolidation, with eye movements indexing emotional memories during sleep replay. A growing minority of researchers believes REM is silent communication between brain regions that cannot speak any other way. None of these theories are fully proven, and the field remains one of the most exciting frontiers in modern neuroscience. What we do know is that REM sleep is essential, and depriving someone of REM completely destroys learning, memory, and emotional regulation. We know that human infants spend most of their sleep in REM, suggesting these eye movements help build the developing brain. We know the eye movements correlate strongly with the most emotionally intense and most vividly visual dreams of the entire night. We know that lucid dreamers, when fully conscious within a dream, can deliberately move their eyes in agreed signals. Researchers now communicate with lucid dreamers in real time through agreed eye movement codes sent across the boundary of sleep. So tonight, when you fall asleep, somewhere around 90 minutes after closing your eyes, the strange nightly show begins. Your eyelids will stay shut, your body will go still, your breathing will slow into a strange, irregular nightly rhythm. And underneath those closed eyelids, your eyes will begin to dart, watching something we still cannot fully name or explain. Maybe a dream, maybe a memory, maybe a perception your sleeping brain is quietly rehearsing for tomorrow's waking world. Sleep well, and remember, somewhere behind your closed eyes tonight, something extraordinary will be quietly watching back at you.